hydrochloric acid is so essential for digesting our food. The issue is that toxins that are produced by this overproliferation of bad microbes in our gut will inhibit or reduce stomach acid secretion, this hydrochloric acid. That produces a condition called hypochlorhydria. You don't need to remember that, but hypochlorhydria, by definition, is low stomach acid. And if you're interested in how that would look in your blood, it's marked in your blood. If you get blood work, you can see that you have hypochlorhydria. Generally, when your protein levels are low, oftentimes combined with globulin levels that are high. That's an indication of hypochlorhydria or an insufficient amount of hydrochloric acid in the gut. That hydrochloric acid is produced in the walls of the stomach. When it's produced, it activates an enzyme called pepsin. Pepsin is responsible for digesting our protein. So if we have low HCl, hydrochloric acid, we are going to have compromised pepsin production, which means that we're going to have trouble digesting protein. It's also interesting to know that pepsin needs an acidic stomach to be able to work properly, a pH of 3 or below. What happens whenever we take antacids, whenever we take protonics? What happens to our stomach acid? It becomes more alkaline. That automatically is going to compromise digestion. Because hypochlorhydria is low stomach acid, that means that stomach acidity isn't acid enough for pepsin to work properly. Now, pepsin and other enzymes can't work effectively, and proteins like gluten and casein and many others aren't digested properly, and it creates a host of inflammatory issues in the body. You see, when food passes into the duodenum, which is the upper part of the small intestine, the food now should have a pH of 2 or less because it was mixing in with all of these acids in the stomach. When you have food that enters the duodenum with a low pH, that stimulates two specific hormones to be secreted by the duodenum. One is called secretin, and the other one is cholecystokinin. In essence, they do much of the same things with a little bit of difference. Secretin tells the stomach to stop producing its juices. It stimulates the liver to produce bile. It also stimulates the pancreas to create this alkaline bicarbonate solution, which is super vital because the duodenum and the rest of the small intestine need more of this alkaline environment to be able to digest our proteins, our fats, and our carbohydrates. In other words, we need a higher pH inside the duodenum, inside the small intestine, as compared to the gut. Cholecystokinin tells the pancreas to produce the digestive enzymes as well. Low stomach acid causes food to be less acidic as it's entering into the duodenum, and then the wall of the duodenum won't make enough of the cholecystokinin, which means that the alkaline enzymes will be compromised, which means that your food digestion will be compromised. In addition, cholecystokinin tells the stomach to stop its activity and makes the gallbladder, and this is important, makes the gallbladder empty its bile into the duodenum to start the process of digesting our fats. Also opens the gates for the pancreatic enzymes to flow in and start digesting the food that is arriving. These two hormones are so important that proper digestion can't possibly happen without them. Remember, trace back low production of those hormones, trace back to low stomach acid. And again, that's traced back to the fact that we have this abnormal gut microbiome producing toxins, which is inhibiting the production of that stomach acid.